Hi, welcome to the first video for Calculus 3 Spring Term 2020 at Clackamas Community College. I'm Amy Brandenburg, and this is a quick introduction to sequences. So we're going to start off with the definition of a sequence. So the definition of a sequence is just a list of numbers written in a definite order. That easy. For our course, we're going to be dealing with infinite sequences. So you've seen finite sequences before, and possibly you've seen infinite sequences. We will not be dealing with anything finite unless it explicitly says. There will be a rare occasion where we have something finite that we're dealing with, mostly so that we can build a new infinite thing. So whenever we're talking about sequences, you can just assume that we're talking about infinite sequences. And I'm going to defer to saying just sequences a lot. And you should know that that means an infinite sequence. So in general, I might write a sub 1, a sub 2, a sub 3, a sub 4, ... a sub n. This gives me my general idea of what's going on. And then again, continue those ellipses on because you want your reader to know that we are talking about infinite sequences. In general, we say that this is the first term, this is the second term, this is the third term, and the fourth term of the sequence. This then would be, my a sub n would be my nth term. Another way I might write that is I might explicitly say what the nth term looks like with a formula, or in general what any term looks like with a formula, put braces around this to let my reader know, hey, we're talking about a sequence. There should be braces around here because technically a sequence is a set of numbers in a definite order. But that's not the biggest deal. That's more a stylistic choice of whether or not you like to have braces. Another more explicit way that I might want to say is I might want to index, I might want my reader to know, hey, what number are we going to start at? Are we going to start at n equals 1 for the first term? Is that the number I need to be plugging in to get my first term back? N's referred to as our index. A lot of times for a finite sequence, you would say your termination number up here. For an infinite sequence, you put infinity right up here where my arrow is. Because we're only dealing with infinite sequences, I'm very rarely going to use the upper part of the index here. It's implied that we're going to infinity when we leave it empty like that. So let's look at some examples. So a common method of describing a sequence is by giving a formula for its nth term. Not all sequences can be described this way, which we'll see in a little bit. So for example, here I'm using that same notation I was using a minute ago where I was saying, hey, look, we're looking at a sequence. We're going to start at 1 and go up to infinity. And in general, a term looks like 2 times n divided by n plus 3. You are only plugging in integers, so I would never plug in, say, 1/2 for n. N must always be an integer. Another general way to do it is just to say, hey, here's the nth term, this is what it looks like, and then if there was any fuss about where n should start, you would put that over here to the side, which we'll see in a minute. And another common way is to just list out what does that look like. So here I've plugged in 1, so I'm going to have 2 times 1 over 2 plus 3. I'm sorry, not 2 plus 3, over 1 plus 3. We're still plugging in 1, so I'm going to have 2 over 4, which is going to simplify to 1/2. When you plug in 2, you'll see it simplifies to 4/5. Plugging in 3 for n will simplify to 1. Plugging in 4, plugging in 5, plugging in 6. So these are the first 6 terms of the sequence, and in general, I would still write my general formula for the nth term. Again, notice putting these ellipses in to let your reader know that you're talking about an infinite sequence. That's really important. All right, example 2. Here we have example 2. So now we've got a -1 in the mix, so I have -1 to the nth power. Remember, if you want to do the trick that I'm doing where my terms are going to go positive, negative, you need to make sure that that -1 is in parentheses when you put it to the nth power. It's those little tiny algebra tricks that you've forgotten about or you're getting rusty at that are really going to trip you up. And there's nothing worse than doing really good in calculus and understanding the things, but not being able to get the problems right because your algebra is rusty. So go get your algebra chops back up if you feel like you're getting messed up on those sorts of things. Here again, I'm saying the explicit term. Notice that there's not really much difference between this one right here and this one right here, other than stylistically how I'm deciding to tell my reader that we're talking about a sequence. I didn't put the index down here. If this is just blank, if all I have is, hey, here's a set and these are what the terms look like, then what's happening here is that it's assumed that you know that you're starting at n equals 1, and it's also assumed that you know that this is going to then be an infinite sequence because the default starter is n equals 1, and if there's not an ending, then you know it should be infinite. So again, plugging in +1, that's where we're starting at. When I plug in +1, I'm going to have a -1, so my first term should be negative. Plugging in a +1 here will give me 1 plus 1, so I'll have 2 on top, and I'll have 2 to the 1 on bottom. So 2 over 2 is going to simplify to a 1, and my first term will be -1. Go ahead, try plugging in 2 and make sure you're getting back +3/4. Plug in 3, make sure you're getting back -1/2. Plug in 4, make sure you're getting back +5/16. Plugging in 5 should give you -3/16. And then again, if I'm writing out my formula, if I'm writing out my sequence and I'm just letting my reader see my sequence term by term by term, make sure you put in that general nth term in there so that your reader knows where the rest of your sequence has come from.